All right, so let's move to the next presentation. It will be by Kelsey Jack from UCSB. The paper is called Harvesting the Rain, the Adoption and Environmental Technologies in the Sahel. And then there will be discussion by Sheetal Sekhri from UVA. Kelsey, the floor is yours. Thank you.
Great, thanks so much. This has been a pleasure to be at this conference so far. I'm going to talk to you about some work with Jenny Aker from Tufts University. And let me kind of put this into context of what else you've seen today. So in Solomon's presentation, one of the bullet points that he had kind of set this up, he said that we may need to do some field experiments to try to understand the role that technology can play in helping with adaptation. And so I'm going to give you an example of the type of thing that I think he was referring to. So we'll be talking about a fairly specific case study and trying to understand some of the barriers to adoption of a technology that has at least the potential to help farmers adapt or at least become less vulnerable to climate shocks. So the context that we're going to be thinking about is, I'll just go ahead and tell you, we're going to be focused on Niger in this study. So this actually also builds nicely on the last project. You heard a little bit about Niger there. And what we're really interested in is the fact that if you look around the world over the last several decades, yields in agriculture have grown tremendously. The exception to that trend is Sub-Saharan Africa. And there are a number of different explanations for why that is, but one of them is that farmers are poor and inputs are expensive. But what it also means is that any increases in aggregate output that we've seen in these regions have really come from recruiting more land into production as opposed to increasing the amount of production on the same amount of land. So this is something that we refer to in the paper as extensification. And what that means is that as new land is being recruited into agriculture, on average, that's going to tend to be less productive land. So this moves farmers into more marginal lands, puts them at increased risk of sort of vulnerability to climate shocks, makes them potentially less resilient. And this sets up a need for agricultural technologies that can boost yields and also restore degraded land. So this leads to this kind of process of land turnover where farmers are moving on to more marginal land. That land in turn gets degraded, and at some point in time, land is getting abandoned. So this is kind of this process of land degradation that also contributes to desertification in the area that we're going to be looking at, which is the Sahel. Now, the technology class that we're going to be looking at is something called rainwater harvesting. There are a number of different rainwater harvesting techniques available. We're going to talk about a very particular one, and that's the sense in which this is very much a case study. We're going to be talking about one very specific technology. This is called a demi-loon. You can see a picture of it on your screen. This is what it looks like right after the rain falls. And so what farmers are doing is they're constructing these sort of raised berms. They're half-moon shaped berms on their fields. This is suitable for degraded land. So farmers are building this on land where the soil quality has deteriorated to the point that the land is largely unproductive. So you can see here, this is very barren land. And what happens is when the rain falls, these kind of raised berms will catch any rainfall, also any topsoil that would otherwise run off the land. So it retains soil moisture, it retains nutrients from the topsoil. These are fairly large. They're about 4 meters by 2 meters, and so they're quite labor intensive to construct them. But other than labor, they don't require much in the way of inputs. You can see a picture here of what these look like sort of during the growing season. Farmers are planting their crops in and around the demi-loons. The area outside of the demi-loons is still largely unproductive. And after a period of about 3 years, agronomists say that the land quality should be restored. That little patch of land under the demi-loon should now be productive again. And then the recommendation is to then just shift the demi-loons to the parts of the land that were not previously covered. Now, if we talk again to the agronomists, they say that these demi-loons have great potential. They show that they reduce soil erosion, reduce the risk of crop failure, increase yields, even increase profits. Yet, if you look around at what farmers are actually doing, you see this kind of classic adoption problem where it looks like profitable technologies are actually not being adopted. In Niger, our estimates suggest that less than 10% of small-scale farmers are using any rainwater harvesting technique. So like a lot of environmental or adaptation technologies, one of the challenges for low-income farmers is that the costs are really upfront. while the private benefits of adoption occur over the longer term. There's also uncertainty in those benefits. We're actually not going to focus on that so much. We're going to focus more on the time scale, this upfront cost with longer run benefits aspect of the technology. And so, we really, in this project, look at some of the often discussed barriers to technology adoption, including lack of information, cash on hand liquidity constraints that might affect that initial investment, but also, credit constraints that might lead to discount rates such that even if this is privately profitable, from our perspective, maybe for the individual farmer, it's actually not. In the interest of time today, I'm not going to talk much about the existing literature other than to say that, we are sort of piggybacking on a large literature that looks at the timing of costs and benefits, how that affects technology adoption. Also a large literature on thinking about the impacts of training. I'll show you as we go that we actually find that training in this particular context turns out to be very effective. I'll spend a little bit of time talking about why we think that might be the case, but also I think importantly, trying to think about how we can use prospective interventions, so sort of prospective research designs, randomized controlled trials, to better test the potential for adaptation technologies to benefit smallholder farmers and other populations in Africa. All right, so the design that we use, this is a randomized controlled trial. The design that we use is to basically try to target these different proposed barriers to technology adoption, and then take as evidence that if those interventions work, that's a sign that that barrier was indeed impeding technology adoption in the first place. So we'll effectively test for the presence of these barriers by designing interventions that try to relax them. This is a village level randomized controlled trial. And so what that means is that a farmer who's in a village assigned to one of the treatments, all of his neighbors are also being assigned to those same treatments. So what you can see in this sort of schematic is that we're testing these different barriers with these different treatments. I'll run through these briefly. There's a paper behind this that provides a lot more detail on what we actually do. But there's a pure control group. Some villages are assigned to kind of business as usual. They get data collection, but no intervention. We address potential information barriers to technology adoption by providing a training. So this training tells farmers about the technology. There's sort of a classroom component where they are taught why it works, how it works, and then they go to the field. And so there's also kind of a hands-on field demonstration where they construct some demi-loons together. All of the other treatment arms also receive the training, and we couple the training with different cash transfers to try to target some of these other barriers to adoption. So we address cash on hand liquidity at the time of demi-loon construction by providing an unconditional cash transfer. So this is timed to occur at the start of the window that it's appropriate to construct demi-loons. Sorry, you need to construct these before the rains arrive so that you can actually be planting in a constructed demi-loon. So there's sort of a particular window of time. It's worth noting that this window of time for construction coincides with the slack agricultural season. And so this is a time when labor is available, but it's also a time of the year where there's seasonal migration, in this case, typically to Nigeria. And so households may have less labor available at that time of year. We also implement a conditional cash transfer designed to affect the kind of time profile of the costs and benefits. So if the reason that farmers are not adopting this technology is that the private benefits are just too far in the future relative to the costs, what this treatment is designed to do is bring some of those benefits into the nearer term by effectively paying a piece rate. You can think of this also as kind of a payments for ecosystem services type of a design where farmers are receiving a conditional transfer based on the number of demi-loons that they actually construct. Now, there's a large literature in development economics comparing conditional and unconditional cash transfers. One of the things that this design makes very clear is that the unconditional cash transfer by design has to happen prior to the desired behavior change, while the conditional cash transfer by design has to happen after the desired behavior change so that the payment can be conditioned on observed behavior. Now, that creates a bit of a confound between, is this just about the timing of the transfer or is it about the conditionality? And so we implement this final treatment over here that you see there's no actual barrier being addressed, which is an unconditional cash transfer timed to coincide with a conditional cash transfer. So you can think of this as kind of an additional control group. I'm not going to talk a ton about this in the interest of time again, but this lays out the design for you. The other detail that's worth keeping in mind is we do 1 year of intervention. So the trainings happen and all of the treatment arms in the early unconditional cash transfer arm, farmers receive payment shortly after the training. The time of training is blind to treatment. They don't know what treatment they're in. But then we follow these farmers for up to 3 years. And so we have some sort of longer term adoption data to try to understand the patterns of adoption over time, what happens not just in the first year, but in subsequent years as well. The study sample includes 180 villages in a particular region of Niger. We selected a random sample of 16 farmers per village for inclusion in the study. It's stratified by gender. I'm not going to go through a lot of gender-specific results because, in part, somewhat to our surprise, we don't see large differences by gender, which I think is its own interesting finding. And actually, it's quite consistent with some of the patterns of treatment effects that I'm going to be showing you. We conduct household surveys at baseline, 1 year after the intervention, and then again 3 years after the intervention. This lets us also see impacts on things like agricultural productivity, labor allocation, and land use. We complement the self-reported survey data with field verification. So enumerators visit the fields of all of the farmers every year for 3 years after the initial trial and count the number of demilunes that are on the field and also validate that they're kind of appropriate construction quality and so on. In the first year, this is the basis for the conditional cash transfer payout, and subsequent years is purely for data collection purposes. Finally, at the end line, we collect data on a random spillover sample so that we can actually see some evidence for diffusion of the technology. All right, so let me get into the results with the time that I have left. The first thing that we look at, and really the focus of this paper, is on adoption. And this is really the punchline of the whole paper. So what you can see here is these are estimated effects in each of these arms relative to the control group on the probability that the farmer had any demilunes on their field. This is in the first year of data collection. And what we see is just a massive treatment effect. So this is sort of totally unprecedented in the technology adoption literature to see a greater than 90 percentage point impact. And what you can see is that in the training group alone, we see this. Because we're sort of maxing out at about 95% of farmers adopting at least one demilune, we don't see any differences across treatment arms in this kind of extensive margin type of measure of technology adoption. If we look instead at a more continuous measure, and this next figure is going to be a little bit busy, I apologize, but let me explain what's going on here. Similarly, these 4 markers are coefficient estimates in each of the training arms. We're also estimating the control group in this case, and this is the number of demilunes constructed by the farmer. And so there are a couple things to note here. In the first year, we see that the conditional cash transfer arm adopts a few more, but relative to the impact of training, this is a relatively modest additional impact. By the 3rd year, both the standard errors have increased, so we see some disadoption, we see a bit of new adoption, and any significant differences across these treatment arms have largely dissipated. The other thing to notice is that in the control group, we see the gradual increase over time in technology adoption, which is going to be consistent actually with what we see in the spillover sample. I'm not going to have time to go through those results with you, so I'll just preview them now, which is that we can compare untreated farmers in treatment villages with untreated farmers in control villages. And what we see is that by year 3, there's a substantial evidence of spillover. So there's sort of social learning going on. Farmers who were trained originally seem to be passing on information about this technology to their friends, to their neighbors. So there's some catch up.
5 minutes.
Okay, great. There's some catch up in the control group, and the treatment arms are largely indistinguishable by year 3. What does this mean in terms of magnitudes? If we look at the amount of degraded land that these farmers actually have that would be appropriate for adoption, we see that this is about 48% of what we might think of as full adoption, which would be covering all of the appropriate land. We do some work in the paper to try to think about, well, is this under adoption? And we don't find any evidence that there are sort of other barriers that are constraining the levels of adoption. Instead, this appears to be just driven by some kind of increasing marginal cost or decreasing marginal benefit that we don't have direct measures of. Okay, so let me show you a little bit of the so what. So what does it mean that these farmers are adopting the technology? What does this do for their livelihoods? The first thing to see here is this is we're pooling now, let me say this, we're pooling now all of the treatments together and estimating the average effect relative to the control group. We can look 1 year in and also 3 years in, so 3 years after the initial intervention. And the main highlight here is that both in the short run and this kind of medium run, we see fairly substantial impacts on agricultural revenue. So this is a value of production measured as a z-score. So these are in standard deviations. We see about a 0.14 standard deviation increase in agricultural revenue, even 3 years after the intervention took place. So this is unlikely to be driven by any cash transfers that farmers were receiving. We don't see much evidence on impacts on crop failures in the medium term, but we do see this kind of impact on land turnover and land degradation. So there's about a 30 percentage point increase in the likelihood that a farmer brought some previously unusable land back into production. So this is consistent with establishing the demi-lunes on unusable land, on land that is so degraded that it can't be cultivated, and a decrease in the probability that farmers had that basically had retired some land in this 3-year period that we observed them. It also decreases their self-reported impact of droughts. We also see some self-reported benefits in terms of soil quality, also some agronomists estimated benefits for soil quality. This is something that we're still continuing to do some work on. If we pull these kind of costs and benefits together, what do we see? We see that even in the first year, when most of the labor investments occurred, I didn't show you our treatment effects on labor, but they're fairly substantial, that even in that first year on average, this technology has private benefits, that the benefits are greater than the costs. If you include data for these 3 years that we actually measure, the labor costs decline substantially, the benefits are fairly persistent, and so what this means is over the medium term, this is even more privately cost effective. Or profitable, I should say. In terms of cost effectiveness, you could sort of probably preview this if you think about this from the perspective of the implementing agency. If the transfer is counted as a cost, then this training only arm is by far the most cost effective, and it's relatively scalable. This is something that we're working on at the moment. Okay, so in the interest of time, let me just provide a few final comments on sort of what we think is going on here. So for those of you sort of familiar with the training literature and technology adoption, these results are quite surprising. It's also surprising in some ways that the cash transfers didn't have larger effects. And so, what it appears to be is that these types of barriers in our particular context are less important at inhibiting this particular type of technology adoption, where the capital needs are relatively small. Labor is something that smallholder farmers actually have in some abundance, particularly during the slack part of the agricultural year. And so information in this case really appeared to be the most important barrier. Why is that? We do some work to try to disentangle this. The study was not designed to pinpoint exactly why it is that training was so effective in this case, but in our case, it appears that it was really sort of a bundle of things. It increased awareness, it provided the necessary technical information, but it also triggered some social learning. So it allowed farmers to work together to share information and potentially some evidence of non-informational channels, things more like motivation. Okay, so where are we at with this? Just to wrap up, we're working currently with the Ministry of Environment in Niger to try to scale up these training interventions. I think in doing so, we'll be able to probe a little bit more about the mechanisms on exactly what makes them so effective. We're also going to do some work to try to integrate remote sensing to try to track adoption over time, and also to lower the cost of actually implementing this if the ministry would like to see whether their trainings are actually effective. So this is ongoing work, and I look forward to your feedback.
Great, thank you so much. Now we have a discussion by Sheetal Sekhri from UVA.
Thanks a lot for, this has been a very educative experience to be in this conference. And I really enjoyed reading this paper. It's very clearly written. And I think that Kelsey already mentioned that, the importance of why this is a very important sort of area to be engaging in was brought out by Solomon's presentation this AM, which is to understand, what are the kind of technologies that can help us adapt to environmental risks or the risks of climate change, and how can we expedite or the technology adoption. And so I think that going by the title, I thought what I'll do is I'll just give you like some pointers about what I thought of contextualizing this work, and also some of the things that you can highlight. Of course, the results you've shown and discussed today are already important for land reclamation. But in African agriculture, irrigation is really, there is no irrigation, so it's a very big issue. And the land seems degraded because of soil erosion. And so the context, it seemed to me, was that you are trying to reclaim these degraded lands. This technology seems to me is a way of retaining soil moisture and prevent erosion, if I correctly understood the paper. And it's not so much about the rainwater harvesting in a canonical sense, in that it's not a storage of water such that you can use it at different time periods and irrigate in a different manner. So I was looking for a discussion of, what are the shocks or environmental shocks or climate risks that are faced by these farmers. Is it just that the land is degraded that they are trying to now optimize and use, or is there some kind of shock also that they will be able to sort of be more resilient towards? If there is, you may want to document the frequency of such kind of shocks and loss from some such kind of shocks. For example, soil erosion is a big deal, and so there is work in the United States that talks about loss of productivity and increase in land value if you prevent soil erosion by this particular literature is using shelter belts, but maybe these demi-lunes are another way to prevent soil erosion. So something about contextualizing it as an environmental technology that I was not sure where you were wanting to go with that. And then in terms of technology adoption, you focus on information versus credit constraints. In case of environmental adaptive technologies, risks, attitudes, and beliefs about the probability of the risks also play a very key role. You do have some result alluding to the fact that the beliefs did seem to be mattering for adoption. For example, some farmers, if they experienced shock last year, they were more likely to adopt. Do you maybe want to sort of develop that a little bit more? Because it seems to suggest that beliefs about shocks or experiences with those shocks are also important. But this, in the paper, I could not figure out what is the shock really. Was it some kind of dust storm or drought, or what was it? So you also mentioned somewhere in the paper that adoption does not vary by baseline risk. So these might be things to bring sort of front and center and discuss them as you lay the discussion about information versus credit or liquidity constraints. In this specific context, in your paper, I wanted to just sort of talk about adoption itself. Usually it follows an S curve, right? So in this case, control group is also increasing its adoption, albeit at a very slow pace. And even the treatment group is not reaching the engineering optimal levels. In the paper, you also mentioned government has a very keen agenda to promote this specific technology, and that's one of the reasons you focused on it. So I wanted for you to think about whether farmers are not reaching optimal technology because of some other reasons. You discuss profit, and it increases relative to cost, but labor is the biggest component of the cost. And you do show results that seasonal migration, for example, goes down, and labor is substituted towards constructing these things. So overall, what do we make of welfare of the households when the production and the consumption decisions are correlated? So what about their consumption or income? Are they better off, not just by profit comparison? Are they really better off doing this? Maybe the opportunity cost of time that they are not able to go as a seasonal migrant where they may have earned more is being stacked against the probability of risk of soil erosion or the benefits net of cost of this technology, right? So just some sense of overall impact on the welfare of the households, not just the profit, would be very useful. One of the things that I think was very interesting was that you have this ability to look at the dynamics, and so here we can learn a lot from this exercise, especially if you're going to continue looking at satellite based data on this, is to see suppose we want to be on the convex part of that S curve where we want to adopt technology. In that there is some catastrophic event and we want everyone to rapidly adopt the technology. What kind of treatments or interventions will make that happen? So here, for example, very early on, your unconditional cash transfers lead to the highest adoption, but then other interventions catch up slowly in year 3. So that tells us, like, if we want to, although the differences are not terribly large, but that's something worth thinking, that that dynamic of in the future, when we are going to think of when we are thinking of catastrophic events related to climate change, and we would want to sort of adopt some kind of technology very, very quickly, can we distinguish interventions that bring us to that part quicker? That is also sort of outside of just the domain of agriculture and environmental technologies currently with vaccinations and such. That's even pertinent in those kind of contexts. And I think that's where I would stop.
Great. We have like maximum 5 minutes. Kelsey, either you can respond to some of the points, or if you want, you can collect more comments from maybe some of the panelists. I didn't see any question in the chat.
Sure. So I'll say a few things in response, and then please, if there are other comments or questions, that would be great. I think the main thing, Sheetal, that I'll try to say a little bit about in terms of the kind of shocks that this is mitigating, I think that it's effectively just trying to make agriculture in general more robust. So this is a very arid environment where rainfall is really a limiting factor in agricultural production, and so anything that helps retain more moisture in the soil should be good for agricultural production. But because this is a technology that's really targeting very severely degraded land, the biggest impact is really on just slowing this process of land turnover, right? It's really about slowing the movement into increasingly degraded lands. It's about reducing farmers' dependence on really marginal plots for production. And so trying to slow that process, which then in turn should have larger effects on things like desertification, which are really a bit beyond the scope of what we're able to see and measure. Although, as you say, the hope might be that that over time we could track some of that in the scale up work using the remote sensing data. So drought, erratic rainfall, et cetera, are the kinds of shocks you should have in mind. But in general, the sort of nearest term thing that we can measure is this process of land turnover and land degradation. And so that's why we really focus on that, as opposed to trying to set up some kind of estimate that would look directly at the shocks. So one sort of meta comment that I think is useful for this group in this particular session is that one of the challenges with these prospective types of interventions to look at adaptation technology is that the ability to see sort of evidence of what looks like adaptation really requires that you see enough heterogeneity in where shocks are actually occurring to be able to see if the technology is actually helping to kind of smooth out the impacts of those shocks. Unfortunately, the weather data in this particular region is fairly coarse, and so we've gone down that road a little bit. I think that's something that we're still hoping we can do a bit better job with, but it is a challenge with RCTs in Sub-Saharan Africa, is that the ability to actually see that kind of variable shock over even a 3-year trial with with a fairly large number of villages involved is somewhat limited. And so I think that's an area that's a very sort of productive area for future research, is to try to think more about how do you set up prospective trials to really test adaptation technologies and to really understand, as you say, not just the profit impacts of them, but the kind of overall welfare impacts of them. So thanks so much for those really thoughtful comments, and thanks for the time.
Let's see. Yeah, Paulina, go ahead, please.
Oh yeah, sorry. Just it's a great project. Super excited to see this. And I just had a comment. I'm puzzled about the lack of response to economic incentives of any kind beyond the training. And I'm just wondering whether there's, some sort of cap on the labor that can be devoted to this, and whether, it'd be worth thinking about broader externalities of this technology and the potential cost benefit analysis of bringing in a different technology to build this demi-lunes.
Yeah, no, it's interesting that you mentioned that. So the FAO is actually doing some work in the region with a tractor that builds demi-lunes. So so this is an alternative. This really switches the adoption problem to being one of requiring an input that farmers have, which is labor, to requiring capital, which requires money, which international organizations like the FAO have, but farmers tend not to have. And so I think it is interesting in terms of thinking about what is the most effective way to target aid. But for an actor like the Ministry of Environment in Niger, the idea that trainings themselves can lead to the amount of adoption that we see, I think to them, that's extremely exciting, because that's something that they can scale, whereas the need to acquire new capital to construct these is a heavier lift for these types of organizations. And in the paper, we talk a little bit about sort of what we can learn by the fact that we see not only this cap on adoption, but also the fact that we don't see a whole lot of new adoption after that first year, which suggests that there may be actually more of a kind of fixed cost, that like labor, every year you kind of go back to the bottom of your cost curve if you're thinking about some kind of increasing marginal cost story, whereas something like land, if they're really constructing these demi-lunes on the soil where they can, like this is very hard soil to work, and really you're running out of land where you can do it, that's going to lead to something that looks like what Sheetal was describing as this kind of less than optimal adoption from kind of an engineering standpoint. But from the farmer standpoint, it may just be that they've done all the land that's usable, and that's a very fixed thing, so that each year we shouldn't expect to see additional adoption at all. But these are great sort of open questions, and we hope in future work to be able to say a bit more about them. So thanks so much.